All right, we're going to start a new chapter today. It's another trig chapter, but this is going to be quite a bit different than the trig that we have done so far. So having a knowledge of your unit circle is going to be helpful this unit, but otherwise it's going to be a lot of new information. Okay, so we're going to start out with looking at these reciprocal identities. So you know that the reciprocal of sine is cosecant. Okay, so therefore, the reciprocal of cosecant is then sine. Okay, so 1 over cosecant is just another way of saying the reciprocal of cosecant or sine. So those two things are equivalent. So similarly with cosine, the reciprocal of cosine is secant. So if I do the reciprocal of secant, that takes me back to cosine. All right, one thing that we had talked about on your unit circle is when you have that ordered pair, that the x-coordinate is the value of the cosine and the y-coordinate is the value of the sine. Okay, then you can find tangent by doing y over x. So if sine is y and cosine is x, then another way to say tangent is sine divided by cosine. Okay, so then if tangent is sine divided by cosine, then cotangent would be the reciprocal cosine divided by sine. All right, looking at your Pythagorean identities. Now, these are based on the Pythagorean theorem. Okay, so right triangle, a squared plus b squared equals c squared, but they are true for these trig functions also. Okay, so if you think about your unit circle, okay, I'm just going to do a real generic unit circle here. And let's say I am looking at a 30-degree angle. Okay, so here's my 30-degree angle. Here's the ordered pair. Okay, the coordinate for this ordered pair is going to be root 3 over 2 and 1/2. Okay, because the distance from here to here, you would go to the right, root 3 over 2, and then you would go up 1/2. Okay. All right. So if we look at this first Pythagorean identity, the sine squared of theta plus cosine squared of theta equals 1. All right. So if we take this 30-degree angle and we do the sine squared of 30 degrees plus cosine squared of 30 degrees, and that equals 1. All right, well, 30 degrees, back to my unit circle, the sine of a 30 degree is going to be 1/2. Okay, so we could substitute 1/2, and then that's going to be squared, plus the cosine of 30 degrees is root 3 over 2, and then that's squared, and that's going to equal 1. So 1/2 squared is 1/4. Root 3 over 2 squared is going to be 3/4, and that equals 1. Okay, so true statement here. It works for any angle, not just the kind of common angles that we've been using on our unit circle, but it works for any angle. And then there's two similar statements using tangent and cotangent. Okay, again, it's just based on the Pythagorean theorem, so it's another way to express that. Okay, so those are going to be some of the things that we're going to be using in the next couple of days as we go through this lesson. You will have, I posted a formula page for you. It's at the very top. And you will be able to use that on quizzes or tests. So you do not have to have all of these things memorized. Okay, so let's go to number 1. We're going to simplify. So we're going to use either reciprocal identities, Pythagorean identities, to rewrite these to see if we can figure out a way to simplify them. Okay, so one method that can work is changing everything to sines and cosines. Okay, because everything, tangent can be rewritten as sine over cosine, cotangent can be written as cosine over sine. So that's one technique that you can use, is try changing things to sines and cosines and see if that gives you something to simplify. Okay. All right. So if we start with this one, tangent of beta times cosine of beta. Okay. This is just another Greek letter. You're used to alpha, theta. Okay. This one is beta. So it's just a variable. It's an x. It's a theta. Okay. Well, tangent, we can make a substitution because tangent is sine over cosine. So if we rewrite this as the sine of beta over the cosine of beta, and then times cosine of beta. Well, if you look here, I can rewrite that as a fraction. And then we have a cosine beta on bottom, cosine beta on top. Those would reduce. And then what you are left with is sine of beta. Okay, so if we go back to the original, tangent beta times cosine beta. Again, we could pick any angle you want to. If we go back to that 30-degree angle that we were working with just a minute ago, we could calculate the tangent of 30 degrees times the cosine of 30 degrees, and that is going to be an equivalent value to the sine of 30 degrees. Okay, so of course, sine of beta, fewer steps, simpler statement to evaluate than doing tangent times the cosine. Okay, so that's kind of what our goal is to rewrite these in a simplified version, something a little easier to handle. Okay, all right, so example 2, using that same type of technique. Well, let's try rewriting cosecant using sine and see if that is helpful. Okay, so I have sine squared alpha over cosine squared alpha plus sine alpha. Now, cosecant is the reciprocal of sine, so that would be 1 over sine alpha. Okay, again, think about your fractions. This can be written as sine over 1. So then I have a sine on top, sine on bottom. That would reduce. Okay, so I now have sine squared alpha divided by cosine squared alpha plus 1. Okay, now here, remember a minute ago we were looking at tangent as sine divided by cosine. So here the sine squared over the cosine squared, that is an equivalent statement to tangent squared theta and then plus 1. Okay, so that is legal to do. If sine over cosine is tangent, then sine squared over cosine squared would be tangent squared. Okay, so that looks better. We actually can go one more step. If you go over here, go back up, look at your Pythagorean identities, look at the second one. 1 plus tangent squared theta equals secant squared theta. So I can simplify this one even more down to secant squared alpha. And then that is as simplified as I get. Okay, it'll take a little practice because you might say, well, I thought that looked really, really good with the tangent squared alpha plus 1. And then I said, oh, we can do one more thing. It'll just take some practice until you kind of get used to, does this look like it's as far as I can go? Or is there something else that I can do with this? Okay, this assignment, along with some of the others in this chapter, it's going to be some trial and error on your part. Okay, you might try something and then it doesn't work out so good, and then you need to back up and you need to try something different. Okay, so we'll talk more about that as we go along. All right, let's look at example 3. Okay, so example 3, we've got cosine times the quantity secant x plus cosecant x. All right, so again, one of our techniques is if I rewrite things using sines and cosines, then that could be helpful. All right, so we're going to go cosine of x. Secant is the reciprocal of cosine. So cosine of x plus, and then cosecant is the reciprocal of sine. So I'm going to make that 1 over sine. Okay, well, you have a couple of options. One thing you could do is add these fractions together. Now, you would need to get common denominators to do that, but that is a possibility that might work out well for you. On this particular problem, it does not help you. It just kind of makes things worse. Okay, so that's not what we're going to do. But we can distribute. Okay, so if I take cosine, because remember, cosine of x, that's like cosine over 1. So if I do cosine of x times 1 over cosine x, I get cosine x over cosine x plus, and then this would be cosine x over sine x. All right, cosine x over x will reduce, and you have 1 plus cosine x over sine x. Okay, cosine x over sine x, well, that is cotangent. So this is going to be 1 plus cotangent of x. And that is as simplified as I can go. All right, if you look back up here to Pythagorean identities, you might look at this one and say, well, there's 1 plus cotangent squared. So can I change it to a cosecant? And that's a no. Okay, so this is 1 plus cotangent, not 1 plus cotangent squared. All right, so in order to be able to use this Pythagorean identity, I'd have to have that cotangent squared. All right, so I cannot do anything else. This is as good as it's going to get. All right. I think we will stop there for the moment. We will have a second part to this, and then I will go through some more of these examples.